So I think I asked you to do these exercises.
Oh, yeah.
Did people have a go at them? Okay.
I draw like a 2-year-old, isn't it?
So let's go through them. So just to remind ourselves what we had. So we had two types of consumers. One had the demand curve 1 minus P. The other type had the demand curve A minus P. I'm ignoring the max for now. We'll set marginal cost C less than A. And the tariff is this clause. Okay, so I said we showed in the lecture that the profits from selling in both markets were equal to 2F plus P minus C times 1 plus A. So they're selling to both types of consumers, so they get two sets of the fixed cost. They make price minus cost profit per unit. Total number of units they sell is 1 minus P to the high types, A minus P to the low types, and total 1 plus A minus 2. That's what cute. Now I don't know what it is until. Okay, so the first exercise was draw a diagram to show this means F has to equal, they'll set F equal to A minus P squared over 2. Okay, so the first thing to realise was that they want to set F as high as possible. So the only limit on how high they can set F is ensuring that both types of consumers are prepared to buy anything at all. The low type consumers always get lower consumer surplus than the high type consumers. So if anyone's going to not want to buy anything, it's going to be the low type consumer. Okay, so you have to ensure that the low type consumer is just indifferent between buying, paying F and buying a certain number and not buying anything at all. Okay, so the consumer surplus of the low type. So here's the demand curve. What is it? A minus P. So this is going to be A. This is going to be A. Price is quantity. And the set price was being set equal to P. This is some price P. So the consumer surplus they get from purchasing at that price, if they didn't have to pay the fixed cost at all, they'd get this consumer surplus, right? That triangle. But they do have to pay the fixed cost, so we're going to choose the fixed cost in order to completely remove this consumer surplus. Okay, so this triangle, this side is sin fact minus P, this is A minus P, so this is A minus P squared over 2. So the monopolist wants to set F equal to A minus P squared over 2. So the next thing was to show that with this F, firms are going to set price equal to marginal cost plus a little bit. So I suppose what we're going to do is we substitute F into profits and then differentiate. So with that level of F, profits are going to be A minus P all squared plus price minus cost plus A minus 2P. Okay, does this simplify? Well, so not really. Okay, it's not worth simplifying. Okay, so maximize profits. We're going to set the first. We're going to find the point at which d pi dp is equal to 0. So derivative of this bit is what? And then let's use the product rule here. So derivative of this, which is 1 times this. Okay, so we just get that bit again. Plus 1 plus A minus 2B. And derivative of this, well, there's a minus 2p here, so this is going to be minus 2, and minus 2p minus 2. So what we've got left is linear in p. So let's get all the p's together. So here we've got minus minus makes a plus, so we've got plus 2p here. We've got minus 2p there. So these are cancelling out, that's good. So we're just left with minus 2p. So put 2p over to the other side. So 2p is equal to everything else. So we've got constants, we've got a 1. We've got a
minus 8.
Yeah, plus a there, minus 2a, so minus 1a, minus a, and then there must be a c as well. So we've got minus minus makes a plus, so plus 2c, plus 2c. So p is equal to, what's the right answer? 1 minus a, yeah, divided by 2 plus c. Okay, so the firm is pricing above marginal cost by some amount that's, so this 1 has come from the high demand type, that's been set to the high demand type. You know, if we could have had the high demand as B minus price, this would be B, so this is some kind of function of both high and low types. Why is it decreasing in A? That's slightly surprising, isn't it? So you think so, you know, here's the low types demand. You might think intuitively that the higher demand was, you know, the more the low types were prepared to pay, the higher the price you'd want to sell. That seems plausible, right? I guess what's going on is that the higher the demand is, the closer the two types are, so the more you can extract through F rather than the price. So in the extreme case in which A is equal to 1, the high and the low types are the same. Therefore, you want to price at marginal cost, so the price is as low as it can be, but then F is really high. So it's slightly surprising to think a little bit. Final bit, does the firm always want to sell in both markets? I guess when you did this, you used my hint. Let's see how far we can go without using the hint. So if they only try and sell to one type of consumers, what type of consumers would they like to sell to? Yeah, the high type, because they can extract those from the high type. So if they're just going to sell to the high type, what are their profits going to be equal to? See that? Yeah, so they're going to get an F from the fixed cost that this high type consumer is going to pay. They're going to make profits of price minus cost times quantity. What's the quantity going to be? It's going to be 1 minus P, right? That's going to be the high type demand curve. So if you're only selling for the high type, then you're just placing that demand curve. So if you just sell to the high type, you make that profit. Just as before, this is increasing in F. We draw the same diagram as before. So they want to set F equal to this area here. This is P, this is 1. So F is going to be 1 minus P squared over 2. Okay, so profits are then equal to 1 minus P squared over 2 plus P minus C times and we kind of know what the answer is going to be, right? We know the answer should be C, but let's just check this through. So if you were to write down the first order condition, what would you get? Well, can differentiate this bit, but it would be, if it wasn't for divided by 2, it would be minus 2 times 1 minus p, but we've got the divided by 2. So it's going to be minus 1 minus p plus derivative of this bit, which is 1 times that bit, is 1 minus p, plus this times derivative of that, which is minus 1. Okay, so minus p minus c. So we've got minus 1 minus p plus 1 minus p, those cancel out, so price is equal to marginal cost. Okay, we kind of knew that had to be the answer, right? So, in that case, the firm would like to set price equal to marginal cost, and they're going to make a total profit of, just substituting back in, it's going to be 1 minus c squared over 2 plus p minus c is going to be 0. Okay, so that term's going to drop out. So if they only sell to high types, this is the profit they're going to make. If they sell to both types, then plugging in again. So when we sell to both types, this was the level of F. That was the level of F. Profits were given by this expression. I will put in prices here. Okay, so A minus P, we've got a minus A over 2 here. So when we do A minus P, we're going to get minus minus. Okay, so it's going to be a plus A over 2. So this is going to give us 3 over 2A. Does that make sense? So when we're plugging the price into this expression, we're going to get 3 over 2A. So 3 over 2 times A. And then minus a half minus C. Minus a half minus C all squared plus, okay, price minus cost, which is just 1 minus A over 2 times this thing, which is 1 plus A minus 2 times the price, okay, which is going to give us minus 2c minus 1 minus a. We've got a minus minus here, so that's actually a plus. But 1 minus 1, so those cancel out, so this is 2a minus 2c. So the 2's can go out and get rid of that too. So we can simplify that. So it's 3 over 2a minus a half minus c all squared plus 1 minus a times a minus c. Does that make sense? Tell me if I make this slip. So the question is whether that thing is bigger or smaller than the expression we had before, which was...
Sorry, can you go back for a second?
Yeah.
Thank you.
1 minus c squared 2. So we want to know which of these is going to be bigger. Yeah, so if you wanted to do it without using my hint, you can multiply out of the brackets, and you'd get a quadratic in C, right? In both cases you get a quadratic in C, you take the difference between the two, it's still going to be a quadratic in C. You find the roots of that quadratic, and that will give you a cutoff for when it's bigger, when it's smaller. But let's do it using my hint instead. So my hint suggested, suppose C is naught, compare the cases when A is a half and A is 3/4. Okay, so I've taken some nice numbers. Okay, so with C is naught, let's call this one pi 2 for selling in 2 markets, and this one pi 1 for selling in 1 market. So in that case, pi 1 is going to be equal to 1 minus c is 0, so 1. So pi 1 would, that's right. So this is if c is 0. Pi 1 is going to be a half, pi 2 is going to be 3 over 2a minus a half squared a times 1 minus a. And I suggested trying. My laptop. What did I say? A is a half. I suggested trying. Is that right? Okay, so with A is a half, A is a half is going to imply that pi 2 is equal to what? So 3 over 2 times a half is 3 over 4, 3 quarters, minus a half, which is 2 quarters, so this is 1 quarter. 1 quarter squared is 1/16. Half times a half is a quarter, so this is 1/16 plus a quarter, so it's 5 over 16. Okay, so in that case, selling in 1 market makes higher profit than selling in 2 markets. But if A is equal to 3 quarters, okay, so the low value types have higher demand generally, then pi 2 is going to be equal to, so 3 over 2 times 3 over 4, which is 9 over 8, minus a half, which is 5 over 8. Can't do arithmetic. 5 over 8 squared is 25 over 64. So 25 over 64 here. 3 quarters times a quarter is 3 over 16. Where were we? 25 over 64 was it? So 25 over 64 plus 3 over 16. 3 over 16 is 16, 32, 64. So that's...
12 over.
12 over 64.
Yeah, okay, go on.
So you get 37 over 64.
Okay. You're better than me. 37 over 64. So that's slightly bigger than a half, right? 32 over 64 would be a half. So in this case, we're better off selling in both markets. Okay, so that was the point of the exercise, but different demand, with small changes in demand, a firm can go from selling in 1 market to selling in both markets. And generally, when they go from selling in 1 market to 2 markets, consumer surplus will actually increase. Because before, if they're just selling in 1 market, then those consumers who aren't buying anything, they're not getting any consumer surplus, obviously. Whereas if a firm is allowed to price discriminate, if they're allowed to set this 2-part tariff, then those extra consumers are then able to buy something, and they get some consumer surplus. So although, their consumer surplus is getting extracted from them because of the F, but welfare is increasing. I shouldn't talk about consumer surplus. Pardon?
Is it in the 2 markets, one or part of them get some consumer surplus, whereas in 1 market all consumer surplus goes to the producer?
Yeah, so when you're just selling to 1 market, you're just selling to the high types, they don't get any consumer surplus at all. You set the fixed cost such that the high type is just indifferent. If you're selling to 2 markets, then you set the fixed cost so that the low type is just indifferent, so the high type will be getting a bit of consumer surplus. Was that your point? When we're looking at whether or not it's good to allow firms to be able to set 2-part tariffs, whether that's good for welfare, the question is just whether, when they set a 2-part tariff, aggregate output is going to increase or not. That's going to turn out to be the important thing. So here we see that in this case, when A is 3 quarters, when we're allowed to set a 2-part tariff, aggregate output would increase. Okay, because if they they weren't allowed to set a two-part tariff. They weren't allowed to set a two-part tariff at all. They'd just sell to the high types, but they'd set a price equal to a half. Yeah. Is this relevant? Well, sorry, I'm stupid. I'm thinking about something else. I'm confusing you. Let me start again. If you're just selling to one market through a two-part tariff, it's always welfare maximizing, right? So a two-part tariff is efficient when you're just selling to one market. So yeah, you can't do any better than that. So it's not the right example for you. Yeah, so this isn't telling us anything about welfare at all, really. It's just telling us when the firm would or would not like to sell to one type or both. Sorry. Okay, then we had this exercise as well. Okay, this is fairly easy. So we just had to show that the high type strictly prefers their bundle to the low type's bundle. Okay, so under the two-part tariff, the high type is getting a bundle. So when the firm is selling to both types, right, they're selling F equals to that, they're selling price equal to that. Okay? And the high type is going to consume, so they're going to consume such that they're just on their demand curve, right? So quantity sold to the high type is going to be 1 minus the price. Okay, so it's going to be 1 minus A over 2 minus C. So that's 1 minus a half is a half. So half plus A over 2 minus C. Okay, so the high types are getting this number of units. They're paying a total cost given by the tariff, right, which was T of cube H. So this is F plus PQ, which is A minus P squared. 2. So A minus P squared over 2 plus price times this quantity that we just found. Half plus A over 2 minus C. So the total amount they're paying there is a function of the price. We just have to substitute in for the price now. So the price is that expression at the top. Okay, so this is just like what we had before, actually. So again, this is that bracket, right? So this is equal to 3 over 2 A minus a half times C squared over 2 plus the price, which is 1 minus A over 2 plus C half. So if you like, this is the bundle that the high types are getting. Okay. Effectively, they're being offered a price and a total cost. Okay. And when we were moving away from the two-part tariffs to look at directly offering bundles, this is one possible bundle that the firm might offer to consumers. You pay this total amount, a slightly messy expression, for this total quantity. So I guess what we want to know is what the surplus the high types get from consuming this bundle. Okay, so the surplus of a high tide is one is price. Right, the surplus of a high tide is given by 1 minus p squared over 2 pardon? Are they consuming the whole? Yeah, they will be. So they're paying some price, they have to be on their demand curve, so they're getting all of the revenue, all of the surplus above that point, but then they're paying this F. So again, let's just substitute in to work out what it is. So this is equal to 1 minus a half, which is half plus 2 so just substituting in. So this is the surplus of the high types get from consuming their own bundle. It's a bit tedious, isn't it? And we ought to be able to simplify this. Let's see what we can do.
You just do 2 counters, which you
Pardon?
say if you times the cheese surplus by 2 and then root it, that'll get rid of it into a nice simple on one side.
No, wait. It's the difference of 2 squares. But you have to multiply out the brackets, right? So this is, so the surplus of the high tides is what we get from multiplying out these brackets. So we get a half in the front, so quarter plus A over 4 minus C over 2. So I'm just doing the terms in order. A over 4 plus A squared. A load of these are going to cancel out, so I know it's horrible right now, but we'll get nicer. Damn, I got it wrong. This one should have been, we're doing A over 2 minus A over 2 times.
Can you
Oh, you can't see any. That's a waste of time. I'm just multiplying out the terms in. So I did the first one times each 3, the second one times each 3, the third one times each 3. So for a load of duplicates, so you get A over 4 in 2 places, you get C over 2 in 2 places.
Oh, yeah. You're correct.
So we were doing this, and then the other one minus a half 9 over 4.
What is the term after a squared over 4c?
It's AC over
Oh,
2.
it's AC.
That was where I made a mistake.
Well, is that like AC or A little c?
It's AC. I made a mistake, so I just had to squidge the C. But
Oh, okay.
it's A times C. It's the same as that term.
Okay.
Okay. I'm just multiplying out the brackets. You can do so.
Not an easy way to do this.
Use a grid method.
I don't.
Use a grid method. So you put it like
Oh.
that and you just type it out into
Yeah.
You never looked at all that?
No.
Primary school.
No.
Primary school.
Secondary school as well.
Just
Oh,
quite
when you
Is
have it
that
from
a
there,
matrix
and then
thing?
you, yeah.
Times like you kind of just add them all up.
Oh, that's magic.
I got told off for using it in A level.
Yeah.
We're still going to use it.
Therefore, you must use it now.
Didn't get discouraged. Crack on it.
So where are we up to?
You plus the other one with minus two. Should this be classical?
Where have I gone wrong? Probably.
Isn't it minus half time? Minus half, which is classical, isn't it? Well, I make you.
Yes, plus is your turn.
And then plus.
Plus C. Yeah, you're right. Plus C over 2. So now this is minus 3 over 2 AC, but then we have plus C over 2, and then plus C squared. Okay, this is horrible, isn't it?
Yes.
On my terms. So, remember I've got a mark first. It's unlikely, but I'm going to say it in the exam.
The first, on the first
Oh yeah, go on.
thing, it should be plus C squared at the end.
Oh yeah, plus C.
There's so much room for it.
Yeah, exactly. We should all cancel. Most of them should cancel out. Can I just trust you?
Maybe, I don't know. My maths is right.
He did it in primary school, he's got it.
Well, in fact, let me. So, you know, I never do algebra. I never do differentiation. Once you get to a certain point, you never. Well, no, obviously I do some. Obviously I do some. But if there's anything particularly difficult, I don't do it myself because I don't trust myself. I use this wonderful program Maple, which is very easy to use. So let's just cheat a little bit. And Wolfram Alpha, yeah, we'll do the same thing. So,
Oh, you told me right? Yeah.
you see that? It's a useful piece of software.
It likes differentiate stuff.
Yeah, the differentiation and all sorts of stuff.
You just have to tell it what it's quite smart, like I like it.
I'm going to do that.
But what I don't like is when I genuinely get stuff that comes now, my opinions and then
Didn't you bring any bananas for your friends? So me? No, not each other. Yeah, dark chocolate is the best one, isn't it? See the other good for you.
It seems like down to this. 1 minus A times A minus C.
Good quality one.
So, 1 minus
Primary school says yes.
A.
What? You buy separate?
Inside now because
Don't ever say that out loud again, please.
What?
I think it's quite
I think I'm
blurry.
We can't see like
It's
the
kind
left
of
side.
blurry.
If you do like shuffle over.
Yeah.
Is that it?
They only said what's the.
So it's horrible, but it all simplifies down
So it simplifies it out.
Yeah,
How did you get to there?
Well,
Like, I don't know in an exam when you get marks for the
so,
shuffle.
yeah, I'm unlikely to make it multiply out there.
Yeah, but how did you get there? If we did that in an exam, would you give us marks or just skip all that?
Well, if you could magically get from there to there in an exam, I think you were a genius. No, it's not difficult simplifying this. You just have to go through and cancel out terms. But just A's and C's and A squares and C squares. It just takes a bit of time. Okay, so this was the surplus of the high types when when they consume their own bundle. Okay, so does this make intuitive sense? Well, if A is equal to 1, they get no surplus. If A is equal to 1, then F is set to completely remove their consumer surplus. if A is equal to marginal cost, okay, so the low types have incredibly low demand, then again they get zero surplus because what's going on there?
Because 0
No.
times everything is 0.
Yeah, but why are they getting zero surplus in that case? Let's get back to our solution. So if A is equal to C, okay, so look at F, I guess. If A is equal to C, then this is half A minus half C. What am I doing? No, yeah. A is equal to C, so this is half A minus a half. That's what I meant.
You're ignoring the bit before where it says C is less
Yeah, we're kind of taking the limit as C goes to A. So the fixed cost in that case is half times A minus a half. But that's the same fixed cost but would remove their consumers. So it's not obvious, is it? What to think about. So that's what they get if they consume their own bundle. The question was asking whether they're better off consuming their own bundle or consuming the low types bundle. If they consume the low types bundle, so they pretend to be a low type, if you like, well, they it's kind of immediate, but it has to be lower.
But consume less.
So the low type, how much does the low type consume? Well, the quantity consumed, can you see that? Yeah, quantity consumed by the low type is A minus P. Okay, so that's A minus half 1 over. So minus minus same thing again, 3 over 2A minus a half. So
To be fair, if you assume that consuming more is better than consuming less,
Yeah, I remember that.
if you just have a look at the two consumption quantities, if they're the same, then it doesn't make a difference. If they're different,
but they're also paying less, right? I don't think it's. You know, so okay, it is immediate from first principles without doing any maths at all, because the high type is choosing how much to consume. Okay, so they would have chosen this bundle if it was better, but
when you do the maths, you can see that
yeah, we want to check anyway. So they'd consume that quantity, they would pay. So in that case, what does their surplus look like? Well, then they're no longer consuming up to the efficient point, right? Here's this quantity L, there's some price here, and their consumer surplus now looks like that. So QH is the point at which is on their demand curve, but suppose for some reason they decided to choose consume less than was given by their demand curve, in particular this quantity QL. Their surplus is going to be by this area. Well, it's clearly strictly lower than that area, so you don't need to do any maths at all. Yeah. So you could have done it without any maths. I'm stupid. Yeah, so to go back to the very start, this was actually a simple thing which I've made complicated.
It's negative.
So the exercise was show that under the two-part tariff considered in our linear example, the high type strictly prefers their bundle to the low type's bundle. Okay, so their surplus is always, if they consume some quantity Q, okay, their surplus always looks like that minus F. So it's this area minus VF. The F they pay.
Minus the D.
Pardon?
No, I think minus the F.
Yeah.
Yeah.
Yeah, so this area minus the F. The F they pay is the same whether or not they pretend to be a high type or a low type. You know, the F is the same for whoever's buying the good. So they're going to prefer a bundle just if it has high quantity. If it has the same price, they're just going to prefer it if it has high quantity, as long as that quantity is less than the one that's on their demand curve. Okay, the bundle offered to the high type effectively has a quantity on their demand curve. The low types are consuming less, therefore the high types have to be worse off. Okay, without any mass at all. So what was the point of this exercise? Well, if the high types strictly prefer their bundle to the low types, then the firm is doing something wrong. You know, the high types are getting consumer surplus, and after all that algebra, we found out how much consumer surplus they were getting, right? They were getting this. So the high types are getting this in consumer surplus, and as far as the firm's concerned, this is waste and profit. So what the high type would like to do is, rather than offering a two-part tariff, what the firm would like to do is, rather than offering a two-part tariff, it should offer a choice between bundles. Okay, it's a price-quantity bundle, and it wants to charge a slightly higher total cost to the high types than it does to the low types. Okay, in order to remove this consumer surplus. I didn't get as far as that. I didn't go through this
No.
in the lecture,
No.
did I? I should have done that.
No.
I guess we'll do it.
Oh, yeah,
So are any of these exercises relevant? I'm not sure if we've covered enough for some of them.
I don't think so.
Line 7.
That was the next step.
Okay, so this, yeah,
Just
these
find where it is out of 4.
These are. So this one, did anyone have a go at these? And we'll do one now and we'll do the rest next week, I guess. So this says, so some monopolist is price discriminating between two markets. For a different. Well, it's third degree.
Sorry, what page is it?
So this is page 92. Just seeing if there's a better one, but.
Not bad.
You trying to spell details? You're an idiot, you don't know. It's the...
This is a more relevant one actually. So those exercises were about third degree price discrimination, which we haven't got to yet. So maybe this one is better.
Is that LD?
Yeah, 13.5. So this this is exactly on,
Yeah,
on
that's
2-part tariff.
So what page is it?
So this is page 358.
Ooh, that's a bit of a disaster.
So, lucky you, you're been appointed chairperson of the economics department at Wonderland University. So you need a new photocopier. You've got a choice between two contracts. One, you can pay 5 cents per page. The other one is you pay a yearly fee of $300 and 2 cents per page. Okay, so that's a 2-part tariff, right? $300 rental plus some marginal cost on top of that. Okay, so this is a nice easy one. Draw the department's total photocopying expenses as a function of the number of copies made each year under the 2 types of contracts. Okay, so let's have expense there and quantity here. Or, you know, the number of copies.
We can't see.
It doesn't.
I think it's like
Zoom out. Okay. So does anyone want to do this? It's very easy. Okay, what am I drawing? Tell me what to draw then. Pardon?
just line.
Okay, so one of them, you know, if you just pay 5 cents per page, then your expenditure is just going to be straight line. Okay. Whereas if you pay a yearly fee of $300 and then plus 2 cents per page, it's going to be something like that. Okay, you pay some fixed amount to buy anything at all, then from then on you're paying in terms of the quantity. So the next part is conclude which contract is less costly given the number of copies made each year. So it's just asking which consumers would prefer. So this is just a question checking you understand what a 2-part tariff is, I guess. So it's very easy. So we've got one line which is E1 is 5 times Q, and then E2 is 300 plus 2Q. Okay, we're measuring in cents, not dollars. So the two lines cross when E1 is equal to E2, which happens when 3Q is equal to 30,000, so Q is equal to 10,000. It's hardly worth doing, but so if you do 10,000 copies, then you're better off with a 2-part tariff. Can we do this next exercise? Not sure it's actually.
We're pushing it. Really pushing it.
Go on, I'll let you go.
Oh.